Good morning, everyone. It's day 3 of reInvent, and 9 o'clock in the morning. You're all here. Congratulations. I want to say I appreciate you. My name is Vinitha Ananth. I'm the product lead for open source data analytics, EMR and Athena services. And I am very excited to be with you today because this is my favorite time of the year to share with you all of the features and capabilities that our engineering teams have been working on for several months to the run-up to this event. And I also want to say thank you to all of you because you've been candid and provided feedback to us throughout the year on the features and capabilities that you'd like to see in the product. And therefore, I'm here to provide you an update on the features that you've desired. With me today are two presenters. We have Mohammed Rehan, who is the VP of Telecom Cell. Mohammed, he leads up IT enterprise strategy and planning. Telecom Cell is Indonesia's largest telecommunications provider. And Radhika Ravirala, she is the principal product manager for open source data analytics.
Good morning.
Radhika is a veteran reInvent presenter, so some of you in the audience might already recognize her and know of her expertise.
Thank you.
Thank you.
As the world continues to run on cloud, we're at the brink of another platform shift, which is going to accelerate generations of innovation and value creation. Artificial intelligence has changed the way we work and will continue to change the way we work, we live, and interact with machines. We expect that the knowledge and information economy will go through a major reinvention, and it will be defined by artificial intelligence and the underlying data that will differentiate your companies from your competitors. As we think of this transformation, the bedrock for successful reinvention lies in how we use AI, augmenting the public language, large language models with proprietary data that is your secret sauce. Data volumes are increasing. They're increasing at an unprecedented rate, going from terabytes to petabytes to sometimes exabytes and petaflops of data. Traditional on-premises data analytics approaches just aren't able to handle the data volumes, and this is because they don't scale well or they're extremely expensive. So we hear from companies all the time that you're looking to extract additional value from your data, but struggle to capture, store, and analyze all the data generated by your digital businesses. And this data is growing exponentially. It's coming from new sources. It's varied in nature. And what's more important is that it needs to be securely accessed and analyzed by applications and people. Your data foundation should offer a range of tools and solutions to address the needs of a range of use cases that you're trying to address, spanning from the traditional data lakes to state-of-the-art large language models. And it should be crafted to have seamless integration. It should also provide streamlined task completion. Additionally, it should be providing end-to-end governance, and it should leverage generative AI as well as machine learning to improve efficiency, speed, and cost effectiveness. You've also mentioned that you have several challenges associated with proliferation of tools. Some of our customers have shared that you use anywhere between 5 to 20 to even 25 tools in your data foundation. And you've expressed your desire for simplification. You've said, you want a seamless, simple, easy to use, unified experience. At the same time, you want the diverse set of capabilities that is required of the platform. Earlier this year, we brought the EMR and Athena teams into one organization, and we did this to facilitate the integration of our products, enhancing our ability to provide you with the diverse, support you with your diverse needs more efficiently. And you will hear, if when you're in other sessions, you will hear the theme of unification and organizations coming together, especially within AWS, more so this year and continuing into 2024. Amazon's cloud-centric platform for big data analytics, incorporating EMR and Athena, are enabled to perform distributed data processing at petabyte scale. Many of you have been using these solutions, and what it does is provides you a range of open source applications to choose from: Apache Spark, Hive, Presto, Flink, and so many more. You've also given us direction on our focus areas for innovation, and it is informed by 4 main pillars. The first is supporting the latest versions of open source frameworks, and we commit to providing the latest and greatest innovations to you through our platform within 90 days. For some of the more popular frameworks, such as Apache Spark, we try to do this within a 30-day period. We also have support for the very popular open table formats. Many of you have adopted the open table formats actively, and therefore we support Apache Iceberg, Hudi, and Delta. In the last 2 years, you've also told us that reducing costs or price performance is extremely important to you. We hear that this is a continued theme going into 2024, and therefore we bring to you the best performance and lowest cost option in the world through our platforms. We are hyper-focused on delivering better price performance through our EMR and Athena runtimes. And I'll talk a little bit more about the performance, price performance, and performance optimization that is typically done by our engineering teams in this regard. We also have provided now a range of options to reduce costs, for example, using spot instances, which harnesses unused capacity in Amazon EC2. We offer the ability to do very fine-grained usage. Essentially, billing is done on a per-second basis, very similar to EC2, so that you're paying only for the instances that are being used, and you can spin up and spin down. And there are several other options for optimizing costs that I will cover in the upcoming slides, but this is an area that we've deeply focused on based on your feedback. Additionally, we provide you a flexible and a versatile platform that offers a batch, streaming, interactive, and SQL workloads. We also have multiple deployment models, that is serverless, EMR and EC2, EMR and AKS, and so on. And last but not least, we're providing a unified data access platform and overall governance, because we understand that security especially is starting to become extremely important across the board. And we have a series of announcements on fine-grained access controls, as well as identity propagation that Radhika will cover later in the session. What is differentiated on our EMR platform is the EMR Apache Spark runtime. Our engineers spend dedicated time in improving performance year on year. We started optimizing the EMR runtime several years ago, and we've gone from 2x performance to 5.1 5 times performance in the latest version of EMR, which is EMR 6.15. And we're not stopping there. There's more improvements coming soon. In addition, because of the widespread adoption of Iceberg, we have run TPCDS performance benchmarks against Iceberg 1.4.0, and that also has seen a performance improvement of 14% over open source Spark. What is important, and something that you've all told us, is that you want 100% OSS compatibility, and ensuring that at any point in time, if you wanted to port away or port to the cloud, that we provide our Spark runtime fully compatible with OSS, and that's how we deliver it through EMR. We've focused on Iceberg for our performance benchmarks. However, several customers are also using Hudi and Delta, and therefore these open table formats are also supported on our platform. Amazon EMR provides support for EC2, M7G, C7G, and R7G instances, which are optimized for big data workloads, and they're running the latest Graviton3 processes. These processes are uniquely crafted by AWS and they're using the 64-bit ARM cores. The synergy between EMR runtime for Spark and the C7G Graviton3 instances results in a better performance, up to 20% improvement in performance, and a reduction in total cost by 15% over the previous generation of Graviton instances. I'm very excited to announce that EMR now supports S3 Express One Zone. If you were at Adam's keynote yesterday, you would have heard the announcement of S3 Express One Zone as the new storage class. And we have done a series of tests to determine what the performance improvement would be with S3 Express One Zone. We're excited with the results. We're seeing a range of 2 to 4x improvements, faster access. And again, with that, it also is going to result in a lower total cost of ownership. We've had several customers trying out EMR serverless in the last couple of years since we released. And while we like to build new services, it's really important to ensure that our customers are deriving value from our new offerings. GoDaddy, which is a leading domain registry and web services provider, determined that they wanted to reduce complexity and empower their organization by their researchers in particular to run data processing at a more optimized at an optimized offering. And we embarked on a journey with GoDaddy to work with them to provide a platform that is based on EMR serverless and Graviton2, and that resulted in 60% reduction of overall costs, but more importantly, they were able to improve the efficiency of their developers by 5x. Bridgewater Associates is using our EMR and EKS platform, and they are powering their financial models. Their researchers are using EMR and EKS in a very similar challenge, reducing complexity, supporting their business growth, but also advancing their security measures. by leveraging EMR and EKS, Bridgewater was able to improve their simulations and increase the usage of the platform for simulations by 5x. You've mentioned that you want a variety of deployment options, and they are for different reasons. Our serverless offering is one of the easiest and simplest way to get started on EMR. And this offering allows for you to start within seconds and scale up rapidly. On your behalf, EMR serverless will manage capacities, choose instances, support versioning and patching, really making it super simple, removing the operational overhead for you to leverage the platform for data processing. EMR and EC2 provides the broadest range of offerings, which includes a variety of open source frameworks, up to 20 plus frameworks to choose from, and even a large range of compute instances to pick from. And EMR and EKS is typically an option that organizations who are already standardizing on Kubernetes choose naturally because they are looking to streamline their instance management or run EMR on Kubernetes container instances that are running other applications as well. So let's dive a little bit more into EMR serverless. EMR serverless has become one of our fastest growing services. It's swiftly expanding. At Peter DeSantis's keynote, you may have heard that he announced several serverless offerings. It is an area that we're deeply investing in. We want to make it super easy, basically take away the operational overhead that our customers are experiencing with some of our offerings, making it super simple to leverage the services for the specific use case. And with EMR serverless, we're making decision-making overheads. We're removing decision-making overheads and making it effortless to use the platform. One of the key value adds that serverless provides is the ability to scale up and scale down with, on demand, and without actually having to go and pick and reserve capacity on machines. EMR serverless also has added a series of features since it's launched a couple years ago. And I'll summarize it in a couple of slides, but I just wanted to let you know that this is a fast-evolving space, and we are going to be releasing a range of features in 2024 as well. One feature that I'd like to dive into today is the interactive experience using EMR Studio. And today you can on demand run interactive workloads. And the EMR Studio provides an IDE, which is based on Jupyter Notebook. And that basically supports PySpark, Scala, as well as IPython kernels, allowing data engineers and data scientists to run their interactive workloads. We're also providing the ability to easily create, visualize, and debug your applications from within Jupyter Notebooks and the EMR Studio environment. And what's really special here is that we're also integrating with Code Whisperer, which is our generally available product, which is a code assist product. The Code Whisperer's primary function is to support your developers in providing suggestions based on code or comments that they're writing, and it will support the efficiency or helping your developers become more efficient in their development. I also want to note that this functionality is not just available on EMR serverless, but also available on EMR EC2 and EMR and EKS. Apache Airflow and AWS Step Functions stand out as two of the most widely utilized orchestration engines for data pipelines on the AWS platform. And I'm excited to say that we are going to be supporting AWS Step Functions on EMR. And so pleased to announce that it's a simple, easy drag and drop functionality using the AWS Step Functions workflow studio. And what it also facilitates is the ability to synchronously track the jobs and track the progress on the functions console as well. So to summarize, the launches that we delivered in 2023 for EMR serverless, we announced Graviton2 support. We're supporting custom images, and especially custom image support for Docker. It's an area that you requested, and we've delivered that. You've asked for job level cost visibility. If you're using either OpenSearch or Splunk to do log analysis, we have integrated CloudWatch for logging capability that can then flow into OpenSearch and Splunk. We've got now the integration with Secrets Manager for you to save your passwords. I mentioned earlier the Step Functions integration and EMR Studio interactive capability. And what's also coming up is improved Spark structured streaming. EMR and EC2 is a very popular offering that many of you are probably likely using today if you're looking for clusterful options. And as I mentioned earlier, we have a range of selection of instances as well as open source frameworks that you can pick from. And that includes Apache Spark, Hive, Presto, HBase, and so on. Several of you had asked for high availability options for instant fleet clusters. So I'm very excited to share the news because this is one of our most requested capability from our customers. We are launching HA for instant fleet clusters. And so your primary node is no longer a single point of failure. In the event of a failure, EMR will fail over to the standby nodes. We today will provide one active node and two standby nodes as a part of this offering. And it will also increase the diversity of instances that you can pick from for these HA clusters. You gave us a lot of feedback on our console, and we took it to heart. We've done a lot of great work, I think, in the area of to bring you the best console experience we can. We also made this console experience the default in Q3 and Q4. And this console experience offers improved single screen create cluster workflow, simplified navigation, better performance, more responsive controls, latest features like workspaces, new cluster configurations, options, and so on. In 2024, we're investing heavily in improving the user experience of EMR, Athena, and a range of data analytics services that AWS offers. So stay tuned. We have a lot more to offer in elevated user experience coming soon. In 2023, to summarize, our EMR and EC2 releases included ensuring that we provided you the latest and greatest OSS frameworks with EMR release 6.1.5. We improved managed scaling to help you with automatic instance selection. We've improved the algorithms behind the scenes. While you're using spot instances, you asked whether you could not only pick based on reduced cost, but also on the availability of clusters. So we've provided that price capacity option to choose spot instances. We've improved startup, the cluster startup times by 35%, and now it's under 5 minutes. We've modernized and improved the EMR console. In addition, we've also added CloudWatch events to support better debugging and providing actionable insights when you're provisioning and scaling your clusters. And we've improved the resiliency of our clusters with our high availability options. So with that, I know we covered a lot here. I would like to invite Mohammad Rehan on stage to talk about how Telecomcell is leveraging AWS platform for their transformation. Welcome, Rehan.
Five, 15 hours difference and also 17 hours flight. But of course, I'm very excited to be here in Vegas and also very excited also to hear what Vinita has been shared, new features, a lot of new improvements also, and a lot of different deployment options also on the EMRs. Now, talking about EMR, I would like to share some story about Telkomsel, my company journey, on using EMR to modernize our critical operational data stores. So we start first with some context on the Telkomsel. Telkomsel is the largest telecommunication service provider in Indonesia. We have around 150 million customers across the nation. Yeah, it also reflected with the huge amount of data that is being flowing in our networks, more than 1,400 petabyte data per month. And we are in archipelago nation, so it's quite challenging to do the full coverage. So we have around 220,000 BTS to cover all of our nations. And in terms of the product and services, Telkomsel initially start first with the wireless mobile connectivity, and then, we have prepaid, postpaid subscriptions, and then we start to grow our business by entering the digital services as well. We have a platform for video, gaming, music also. And just recently, Telkomsel acquired our parent company product. It is called IndiHome, so it's a fixed broadband product. So now, since 1st July this year, Telkomsel has become the fully fixed and mobile convergence communication service provider. Yeah, I'll continue with some sharing on the cloud journey on Telkomsel. So we started a bit late actually. Telkomsel started the cloud transformation journey around 2 years ago. The restriction and regulation in Indonesia is quite strict, so we're having some difficult times to convince our government. And fortunately, we are able to do that, and it is coincidentally almost the same timing with the AWS Jakarta region opening, so it's a good timing. So why we start our cloud transformation journey? It is because along the way we continue our digital transformation, we build more digital applications, we have more product offering, innovation, we start to have some issues on the agility, scalability, resiliency, is quite common to all the enterprises and the IT company. So having said that, cloud is not only about the moving from on-prem to the public cloud, but we set up the cloud journey as part of our critical business strategy, transformation business strategy. So in order to accelerate that, we set up Cloud Center of Excellence. So this is the team that have the responsibility to kickstart the adoption of the cloud. We train a lot of people, and now almost more than 100 people of our employee already AWS certified. So we work with the AWS to kickstart the strategic partnership. We already migrate some of our workloads, especially those in the digital products channels. For example, My Telkomsel apps, it's like self-service apps for our customers, and also mobile application for resellers and virtual assistants. Now we came to the data part. So as almost every telco industry, they are have a variety of the product. We have big data also, a lot of type of the data. For example, the network data. So we need to ingest like network quality data, location data, people movement, and also the core BSS system of the telco itself, like the customer care, the order management, payment systems, and so on and so forth. So we have around 1,000 data sources we have identified and ingested into our big data platforms. And in terms of volume, is around 50 terabytes of data ingested per day. And the growth is also quite high, almost 20% per year growth. So we use this data a lot for operational improvement and also for customer service operations. We did also some data monetization. We sell insight as a service to our partners, B2B services. And yeah, we work also with our network team to do network optimizations. Now, as the data grow continuously, especially after the merger of our fixed product, so the data scale is something that we are currently very difficult to handle, especially in the space of data center is very limited also right now. It's not easy to spawn a new data center, of course, and not to mention the complexity of maintenance and the infrastructure. So this is the background why we decide to continue our journey in the cloud transformation. After migrating our digital apps, we now start to see whether we also need to migrate our big data and analytics workload. Yeah, finally, around a year ago, we decided to do it. So we start first with the three main components. The first one is the operational data store, which will be the main focus of this session. So operational data store is like ODS, operational data store that is connected with various mission critical applications. So data is quite big also, 7 terabyte data ingested daily. And there are some non-functional requirements around this, so we expect very minimum downtime, below 2 second query response, and also around 1,000 queries per second. So initially, before we migrate, we use open source on-prem Hadoop, so stack like Spark, HBase, and also Impala. So this is the one that we are migrating to Amazon EMRs. The other two is on the fast analytic data warehouse, which we move to Amazon Redshift, and the machine learning services that we move all the services into the Amazon AKS. We talk a bit more detail on the operational data store. So this is the design of the solution architecture diagram that we have we use. So as the source data, we have 11 applications. This is sit on our on-prem data center. And we also established the AWS Direct Connect to have more reliable and dedicated connection to the AWS public cloud on the Jakarta region. So we use the AWS Data Sync to pull out the data, then store in the S3 bucket as the landing zone first. Then we use Spark that is running on top of the EMRs that to do the ETL, filtering, all those stuff. Then as the result, we store in another S3 bucket in the format of the HBase. So for the EMR, for the query itself, we deployed in the two AZ. The one is the primary cluster, and the other one is the read replica. So we use Apache Phoenix. This is for the layer to do query, to translate the SQL query used from all the consumer of the data to retrieve the data from our ODS. There is a load balancer also, of course, to distribute the traffic. So this is the example. At the right, you can see some of the consumer of the application, like our e-billing aggregation, customer care applications, and also our middleware, and there is a requirement also from our law enforcement. Yeah. Okay, so this is the last part of my session. So having successfully migrated to EMR just recently, we are able to get a lot of benefits. Yeah, the first one is on the open source compatibility. As we know, previously we used OpenStack software also on the on-prem, and it is smoothly compatible, running well also on the EMRs. Not only compatibility, but also we see huge improvement also in terms of performance, in the query latency improve, and also the reduced resource utilization also being reduced. I've also forgot to mention that for our read replica cluster, we also use Graviton instances, so it further improve our cost optimization. So this is also empower our business to do more analysis, and in the end, it can provide a better services to our customers. In terms of the data refresh cycles, so previously, since data is quite big, we need to ingest it, and the refresh cycle we can only do in the daily. Now, after migrating to EMRs, we are now able to do it in hourly manners. Then on the automation, this is also a lot of our effort now being optimized, because previously we need to maintain the cluster by our own, need to do upgrades. But now, since the EMR is managed by AWS, then all the automation can be done automatically, and also the times required is only around 30 minutes per cluster. It's quite fast. So in the technical aspect on the key learnings, so first part on the loading part, so this is where we work together with the AWS team to define how to optimize the process and also the time required to execute. So on this, we use a predefined key range and also choose the correct loading method, so that for the initial data load, we are able to meet the required time frame. So in the fine-tuning of the parameters, of course, by default, EMR already has a good configuration, but sometimes in the large scale or huge scale, you need to do some fine-tuning of the parameters. For example, like the JFrame parameters and also the caching size. Yeah, last part on the project implementation. Of course, this is quite complex project, so we work collaboratively with AWS and several other partners. So yeah, this is a one-team effort, and AWS also put their best people. So yeah, we are able to do this and successfully, and we also looking forward to do more on the BI and the analytics space. Yeah, I think that's all from me. Hope you can find it useful, and I'll now pass the floor to Radhika to continue. Please.
Thank you, Rehan, for walking us through Telkomsel's really engaging journey through modernizing operational analytics. So before we get into the next topic, a quick show of hands. How many of you currently run Kubernetes in production today? Awesome, that's quite a lot. And how many of you are running EMR and EKS? Okay. And just out of curiosity, any EMR serverless fans here? Okay, we hope to convert you. So EMR on EKS is a deployment option that allows you to run open source frameworks on Amazon's EKS, which is Amazon Kubernetes service. This is the service, or this is the service that has been available for a couple of years now. And you can only focus on running your analytic workloads and leave the burden of building, configuring, and managing the containers that are required to run your open source frameworks to EMR on EKS. So in addition to doing all that, there are a lot of benefits why customers actually love to run their workloads on EMR on EKS. For instance, if you're already running your applications on EKS, it makes a lot of sense to simplify the infrastructure management and reduce your resource utilization by consolidating all your EMR workloads onto EKS. You can take advantage of the multi-AZ characteristics provided by the underlying EKS and spread your cluster nodes across AZs to get that resiliency. You can also use cost-saving options like spot instances as well as the savings plan, which will optimize your costs for running on EKS and also help you run workloads more efficiently. There are also a lot of things that we have taken from EMR on EC2, such as you run the same runtime environment as EMR on EC2 for Spark. It's the same runtime, so you get the same Spark performance. You have a lot of other things that we carry on from EC2, which includes monitoring of your Spark jobs through integration with CloudWatch and S3. And most importantly, going back to the cost optimization, customers have often relied on auto-scaling. Now, auto-scaling is provided on EMR on EKS through a feature called Carpenter. Now, Carpenter allows you to horizontally scale your container nodes and also allows you to bin pack your containers with a diverse set of mixed-sized instances to make for improved efficiency and reduce costs. So overall, there are a lot of advantages to running your workloads on an EMR on EKS deployment options. Because this is so important in terms of reducing your costs, we have been focusing a lot on auto-scaling. So to that end, we have added a new feature in auto-scaling called vertical scaling, or the dynamic pod auto-scaling. What this feature does is it allows you to configure your memory, automatically configures the memory and CPU requirements to adapt to your provided workloads and scale the container vertically, allowing you to not worry about manually doing any of the tuning of your EMR on EKS clusters because they are often cumbersome and complex. The beauty of this feature is that it works in conjunction with Carpenter and Kubernetes cluster autoscaler, which means that if you're already using horizontal scaling, you can add this additionally to improve the efficiency of your workloads and run them without having to worry about any kind of tuning. Another feature that we added to help our customers run stateful computations on streaming data is support for Apache Flink on EMR on EKS. Now, with EMR's release 6.13, we started supporting the Flink Kubernetes operator on EMR on EKS. Now, with this operator, you can submit your jobs to an EKS cluster simply directly by submitting the job to this operator. You can auto-scale based on the SLAs for your upstream data using both the horizontal and vertical scaling that we just spoke about, and you get improved resiliency with multi-AZ EKS benefit as well when you're running your Flink applications. So the other advantage of running your Flink applications using the Flink Kubernetes operator is once you deploy the operator onto a Kubernetes cluster, the operator will manage the lifecycle of your Flink application. So besides the dynamic pod auto-scaling and the support for Apache Flink on EMR on EKS, we have been busy with adding bunch of other features on the EKS platform. And they include native Spark UI support through the EMR console, which means that you can go see your virtual cluster, pick up your job, and you can look at the Spark UI for the job. We have also improved the efficiency of analytics and ML workloads with the addition of the Spark Rapids Accelerator integration. This is the NVIDIA Spark Rapids plugin that you can use to accelerate your data science workloads. There are other things that are interesting from an observability point of view, that has to do with integration with Prometheus and Grafana, S3, as well as the CloudWatch integration, which means that you have clear visibility into how your jobs ran, the resource consumption for your jobs, as well as plan on how you want to launch your clusters going forward. We have also improved the performance with Java 17 by adding support for Java 17 and the Amazon Linux 2023 support to this platform. So switching gears a little bit and moving to Amazon Athena. So Amazon Athena, as you all know, is a service that allows you to query all your data using SQL or Python. It is very simple to start, instant start. You put your data in S3, point your query to that data, and start running your queries. So it's serverless. There is no setup required here. It's optimized runtimes for fast results. The engine powering Athena is Trino, and it supports a variety of use cases, which include interactive as well as advanced analytics. So, for example, if you want to run federated queries across multiple data sources, you can use Athena today and simply use one of the connectors and start running your queries. And you can use, you have the flexibility to use any language of your choice that includes SQL or Python. We support two engines on Athena. One is the Spark engine, as well as the traditional, the first one that came, which is the SQL engine. You can use either one of those engines depending upon your workload. It's also very cost effective because you're only paying for the amount of data scanned for your query. You only you're able to save up to anywhere from 30 to 90% per query cost through compression of your data. So you can use the open table formats that Vinitha talked about earlier, compress the data, and query the data using Athena. So on Athena, we have been introducing some new features, which include running queries using provisioned capacity. Now, traditionally, customers who have been running advanced use cases on Athena have had some challenges, and they include queuing. If you submit high volume of queries to Athena, chances are that those queries are getting queued, and it is causing a disruption to your business applications. The second challenge that we had seen and heard from customers is customers run differentiated workloads, which means some queries are more important or they have a higher priority than other queries, and customers want to prioritize to run those queries before some of the other ones. And lastly, customers also have been interested in having predictable costs for their queries. So we designed provision capacity to address these challenges. It is focused on giving you more control over the workloads while retaining Athena's serverless user experience. It is fully managed, and you get complete control over the concurrency and scale of your queries, as well as decide which queries you want to run as a priority. The fastness is something that is always on our agenda. We are constantly striving to improve the performance of the engines. Athena is no different. So we recently added support for cost-based optimizer. This is a feature that allows the query planners to accelerate query performance. It leverages the table and column statistics from Glue Data Catalog. So we added that capability into the Glue Data Catalog to generate these statistics, so the CBO can start leveraging this. And when query starts are available, the CBO can take the most optimized plan and execute that query using that plan with respect to keeping in mind costs and the optimizations. It is tuned by default on configuration. There are no changes required from you, which means that it's available out of the box for you. As Vinayta was talking earlier about S3 Express One Zone, this is a new storage tier that was introduced by S3 at reInvent, and Athena is happy to support this zone. So if you are interested in accelerating your queries for high performance, you can simply store your data in this storage tier and point your Athena queries to it. In our benchmarking, we found it up to 4 times higher performance applications without changing any of your SQL code, which simply means that you take your existing queries, point the data to the S3 Express One Zone, and start running your queries, and you will see this performance difference automatically. You can also query against the data stored in Glacier. So Glacier also has it's a low cost and cold storage tier in S3, and up until now you weren't able to run queries against Glacier. So this year we added support for that. And the last thing on the storage side is we added support for S3 Object Lambda that lets you add code to modify your data on the fly. For instance, if you have sensitive columns that you want to mask before you run the query, you can kick off the S3 Object Lambda feature. And on the user experience side, we have heard from a lot of customers who are using single sign-on through EMR Studio or some such applications to have a similar experience for Athena. So we added support for running Athena queries from Amazon's to EMR Studio. So you can query all your Athena databases, tables, views, and also toggle between different work groups in Athena and run your queries against these work groups, and also look at the saved queries, recent queries, and all the things that you're familiar with Athena on the console. You can do that on the EMR Studio as well. It gives you a simplified experience, and it is primarily designed for analysts who are also using EMR Studio. And another addition to our Athena features is the support for CloudTrail Data Lake. So you can analyze the CloudTrail Data Lake with Amazon Athena. Earlier, there was a lot of setup that you needed to do. You needed to get all the logs from CloudTrail, put them in S3, cleanse it, and then run your queries. With this addition, you can query and analyze your CloudTrail data lake and join it with other data sets using Amazon Athena. So a lot of times for auditability and for other reasons, customers often combine CloudTrail data with other data, and this lets you do it very easily. You can also visualize and build dashboards using QuickSight with your CloudTrail data, and these CloudTrail data lake tables are available in the Glue Data Catalog if you want to explore them through Athena as well. So most of you know Amazon Data Zone as a service that helps you govern data access, and we have been fortunate to add support for Data Zone this year for Athena. So with Data Zone, you can discover your data, share your data, and make it available for consumption layers like Redshift and Athena to query that. So we have added support for Data Zone earlier this year for customers who want to set up environments, discover this data, and do a simple click on their Data Zone environment to run queries with Athena. So security is job zero at AWS, and And so I'm very excited that we have added a number of features on security with both Athena and EMR this year. So on the Amazon EMR side, we started our support for native LDAP integration in summer of this year. This is a feature that allows you to simply use your corporate directory servers, such as OpenLDAP or maybe Microsoft AD, and integrate that with your EMR clusters and have your users sign in using those corporate identities. Now, earlier, before we had this native integration, you could do this manually, but it was laborious, and you had to do it for each application that you were running on EMR. For example, if you had Presto, Huey, and Hive Server 2 that you were running, you would need to individually configure each of these applications with LDAP to make it work for your users to sign into these applications. With this, all that pain is gone. You simply launch your cluster with LDAP integration, and this can be specified in a security configuration, and you can use any of the supported applications, which includes Apache Livy, Hive Server 2, Trino, Presto, as well as the Hue interface to interact with your cluster. And best part of all, customers who have been setting up Kerberos in order to use Ranger, they no longer have to do it. You can simply integrate your EMR cluster with LDAP and then start using Apache Ranger. Another important feature that we are very excited to talk to you about is called Trusted Identity Propagation. This is a feature from AWS IAM Identity Center, and it's a feature that allows you to have corporate identities authenticate to analytic services such as Amazon EMR, Redshift, QuickSight, Lake Formation, the Glue Data Catalog. And we'll be adding support for Athena shortly for this feature. The beauty and the advantage of this feature is that you can bring in your corporate identities from the identity provider that you're using currently, which includes maybe Okta, Azure AD, or Microsoft AD, and use those identities to log into EMR Studio as well as interact with the EMR cluster through the Studio. It also propagates this identity to the downstream services that also support trusted identity propagation. And most important of all, you have the end-to-end auditability for the journey that the user identity took from the beginning all the way to the last application in your call chain. So if you take a look at the diagram on the right-hand side, it depicts how the journey looks like. You have an admin who actually creates, integrates your IDP with the IAM Identity Center, and then the admin creates the Identity Center applications for your analytic services such as EMR Studio, EMR on EC2, Lake Formation, S3 Access Grants, and CloudTrail. And then the user simply logs into EMR Studio. The user identity and the context is passed right from the moment he logs into EMR Studio, and it appears in the CloudTrail log in that whole call chain. So we are also excited to talk a little bit about fine-grained access control. Previously, EMR supported fine-grained access control using Lake Formation, but this was only supported at a column level. But we recently added support for table, column, row, and cell level support with Lake Formation, which means that if you have your data lake and table set up in the Glue Data Catalog, you are able to simply use Lake Formation with your EMR on EC2 clusters. The other things that you get out of this is it also supports all the OTFs, which includes Hudi, Iceberg, and Delta Lake. You can apply data filters on the nested attributes if your columns have child columns. And then you can also access control. You also get access control for your Spark and Yarn UIs. So I know we have a lot more to cover in terms of security, but We are out of time today, so I want to thank you for joining us today for this session, and we'll be happy to take any questions outside the room. Thank you very much.